some of the things that fall out of this particular equation. Let's think first about a case where this delta H naught is less than 0. What type of reaction is that? Exothermic. All right, so now let's consider a case for this exothermic reaction where we're going to increase the temperature. And so that means that T2 will be greater than T1. We've increased the temperature. So now let's think about what sign the natural log of K2 over K1 will have if these things are true. So there's a minus in the equation. Let's put the minus down here. Delta H naught is negative. It's exothermic reaction, so that's another negative sign. And if we're increasing the temperature and T2 is greater than T1, then this temperature term will also have a negative sign. So if you have negative times negative times negative, you're going to get a negative for your net result over here. And what that will mean in terms of K2 and K1 is that K1 will be greater than K2. So you can think about this mathematically by running through this argument. You can also sort of think about it in terms of what you would expect if you increase the temperature in terms of what's the relative ratio of products to reactants at equilibrium for an exothermic reaction. So if you're increasing the temperature of an exothermic reaction, the reaction would want to shift in the direction to absorb that heat in the endothermic direction. So you would expect that the equilibrium constant that was at the lower temperature would be larger than the higher temperature one, that there'd be less products at this new higher temperature. So again, you can think about it in terms of Le Chatelier's principle, or you can run through with this equation and do the math and think about the relative size of K1 and K2. So now let's think about what happens when you decrease the temperature, where T2 is less than T1. So we can do the same thing. We have a negative sign here. We also have a negative sign for delta H. It's an exothermic reaction. But now we have a positive sign for this temperature term. So overall, we're going to have a positive sign for the natural log of K2 over K1, which mathematically is going to mean that K1 is less than K2, or that you would expect more products in the equilibrium constant at higher temperature. All right, so that's an exothermic reaction. So if you're ever having problems with Le Chatelier, you can go and use the Van Hoff's equation to think about what you would expect in terms of this shift, what you would expect if you change the temperature of an exothermic reaction in terms of the magnitude of the new equilibrium constants. All right, now you can do the same for me in terms of in terms of this delta H naught is greater than 0. Which of the following are going to be true? And notice there's a possibility that all of them are true, or that just some of them are true, or that one of them is true. All right, let's take 10 more seconds. See, actually, people did very well, because E is also true. All of those are true. But D was also true. So if we add the 30 and the 58 together, I'm very happy. All right, so let's look at this over here. We'll keep the questions up, and let's consider all of them in order. So the first one is that the reaction was endothermic. I think everybody saw that as being correct. Okay, the second one talked about the equilibrium constant is higher at higher temperatures. So let's look at the first one. We increase the temperature here, and we see that if you work out the math or just think about it, K2 is larger than K1. So the second equilibrium constant is greater than the first when you increase the temperature. So that would favor then in an endothermic direction